Then we move on to like calculating the basic price based features for like the returns, the log returns, and the price change. And then we add like the day based features for day of the week, a month, quarter, and year. And then afterwards, we basically print this out by using data.head. Basically, the basic features that we created are price all the way to like year. And then here's the new data set with this. So as you can see, day of the week is now. And now here's the new data set with this. As you can see, month from now has changed like to a numerical category. So this is like January. January becomes 1. And then we have the day of the week, which like each number corresponds to like whether it's like Monday, Tuesday, or Wednesday. And then we have the quarter over here. So yeah. Next, we move on to creating lag features. So lag periods is equal to 1, 2, 3 all the way up to 30. Basically, this is like the lag features for different time periods. Then we move on to for lag in lag periods, data price lag, lag equal to data price dot shift lag. Basically, this creates like a lag feature for the price labels, and then this creates like a lag feature for the return lags, and then this one creates like a lag feature for like the price change lags. And afterwards, we basically print out the created lag features, the total columns by using length.data columns, and the lag feature columns by using lag columns is equal to call. For call in data columns, if lag is in call, print lag columns 10. Basically, this print out the first 10 lag features. So this is the created lag features, total columns 27. Here are the lag feature columns from price lag 1 all the way till return lag 1. So yeah, then we move on to visualization correlation between like current price and lag features. So price calls is equal to price plus call for call in data calls if price lag is in call A. Basically, this selects like the current price plus like the first 8 price lag features, and it creates like a focus subset for correlation analysis later on. And correlation matrix is equal to data price calls for correlation. Basically, this calculates the person correlation coefficient between like between all price columns. Then we move on to plt.figure fixed size is equal to 12 to A, which creates like a figure of size of like 12 by 8 inches, and then we use Seaborn to create like a heat map for the correlation matrix. And then afterwards we basically plot the title, and then we basically lay it out over here. So here's the correlation matrix, which is like the current price versus the lag features. So basically you can see in this visualization, the warmer it is, that has like a higher correlation as opposed to the bluer it is. So for example, something like price lag 15 has a higher correlation with something like price lag 20 as opposed to like price lag 15 as opposed to like price lag 10, which has like a less correlation with price lag 20. So yeah, then we move on to correlations is equal to data brackets price call for correlation price sort values ascending is equal to false. Print correlation from 1 to 11. Basically this shows us like the top 10 correlations, so correlations with the current price. So price lag 1 has the highest correlation with 0.98 9632 all the way down to price lag 20, which is a correlation of 0.692231. Then we move on to calculating rolling averages and moving windows. So our rolling windows is equal to 3, 5 all the way to 50. This basically defines like different time periods for calculating rolling statistics. Then we move on to for window and rolling windows, data is equal to SMA, window is equal to data price rolling window mean. Basically this calculates like the average price over the specified window period to show if like the price is like on an upward or like a downward trend. Then we move on to printing out the rolling standard deviation by using data sd.window is equal to data price rolling windows equal to window.sdt. Basically this line of code basically measures the price volatility over like the rolling window, as higher values tend to have like more volatile periods. Then we move on to like finding the rolling minimum and maximum by using data min window is equal to data price rolling windows to window.min, and then the same thing but for the max. So basically this line of code basically helps us track down like what's like the highest and like the lowest prices with like within each window, and this helps us identify like a recent price extreme. So yeah, then we move on to price position within a rolling window. So from data price position window is equal to data price minus data minus min window divided by data max window minus min window. Basically what this line of code does is it basically normalizes current price within like the rolling window average as now 0 is minimum and 1 is like basically is assigned at the max. Then we move on to for windows in 5 all the way to 30, data return main is windows is equal to data returns dot rolling window dot mean. Data returned std is equal to windows data returns dot rolling windows equal to std. Basically, this provides us like the rolling return statistics. Then we move on to rows calls is equal to for call in data columns if n x in call for x in SMA all the way to max brackets 10. Basically what this line of code does, it basically shows us like a sample of like the newly created features for like the verification process, and then we afterwards we print the sample rolling features so using rolling calls. So here we have call returned rolling call features, total columns equal to 75, and here's the sample rolling features SMA 3 all the way to STD 7. So yeah, next we move on to basically visualization with Go by using import plt.graph object as Go. Fig is equal to go.figure. Then fig add track is go scatter with these parameters over here. Basically what this line of code does is it basically plots the actual like stock price by using data.index is -200. Basically this uses the only like the last 200 trading days for like clarity, and this allows us to see the actual price serves as like a baseline to compare like against all the other moving averages, and the actual price serves as like a baseline to compare the other moving averages. So yeah, then we move on to colors is equal to blue, red, and green, and orange. Basically assigns the colors for each of the different stock. Then we move on to for I window enumerant 5, 10, 20, and 50. All the way till lines equal to dot colors is equal to colors. For I module length colors width is equal to 1. Basically what this block of code does is it adds like multiple simple moving averages for with like different time periods. So for example, SMA5 means it's like a 1 week period as compared to like SMA 50, which is like a long-term period of around like 2.5 months. So yeah, afterwards we've titled the plot and we labeled the x and y axes and give it the height, and then we plot it over here. So here's our visualization for the stock price with moving averages for the last 200 days. So this stock shows like a consistent like downtrend from like around July 2020 all the way to like December 2020. Basically all the moving averages are like sloping downwards. Basically this confirms that there probably was like a bearish trend in the market which caused all the stock prices to go in a downward trend.